light cord at home. If you have a light sitting on a table or something, the cord has insulation on it, right? What if your cat chewed on it? You can electrocute your cat. Also, what about starting a fire maybe even? Okay, so the insulation's on there, but it's not alive, is it? No, but the insulation on your axons is alive. Do you know your axons can be insulated? And it's called myelin. Myelin, I just erased all of it. There it is. Myelin is the insulation on your axons, but it's not on the rest of it. It's not on the neuron cell body. You don't do that. You myelinate the axons though, but some are and some aren't. Okay? It's kind of a fatty substance. So I just want to introduce that idea to you. We're going to look a little further. This is on, you know about axons. You know what goes down the axon? Action potential. Okay, what's at the end? The boutons. What's another term?
Synaptic. Something.
Yeah, don't even worry about that.
Terminal.
Terminal, axon terminal. Yeah, they got another one that I never see anywhere, so I'm not even worried about it. Okay. So isn't that something? The cord for your lamp at home is not alive. At least the coating on it is not. But in axons in the body, the coating is actually living cells. That's kind of fascinating, isn't it? Have insulation made of living cells. What do you do for a living? I'm insulation. Okay. So we want to go from there, and we're going on to the next chapter. So let's go ahead and do that.
Didn't they do studies to realize that the myelin sheath actually like speeds up the transmission?
It does speed it up. Yeah, it speeds it up. And what's even crazier is it has gaps in it. And yet, instead of slowing it down, it speeds it up because of the gaps.
Right, it's like a magnet.
So we'll get just so far today. We won't get too far. We'll get somewhere. We're going to start out here on page 391. 391. Okay. They wanted to show you here. They wanted to show you some things about the nervous system. So they gave you an example. This person's eye is seeing a glass of water. And how do we know we're seeing a glass of water?
The light reflects from the glass of water?
The light does too, but you still don't know unless the message gets to the brain. So how does the message get to the brain?
Neurons.
Which kind?
Somatic motor neurons.
No, motor is to make something move.
Optic nerves?
Optic is part of it, but it's sensory.
Sensory neurons.
So you're using sensory input into your brain to even know there's a glass of water over there. Okay? So that's coming in. Sensory input coming in. But the brain, what's it gonna do? It's gonna process, and say, oh, I want that water. So I'm sending a command out to the biceps brachii to lift the water glass to my mouth so I can have a drink. So see what's going on there? Sensory input, integration it's called. This is called integration. And then motor output. So that nervous system's functions, that's what it does. Okay? There are different parts of the nervous system. So this person is telling us, there's our brain, there's the spinal cord. What are these yellow lines? Nerves, what's the biggest one? Sciatic, which comes out from under piriformis, right? Okay, so we're getting a picture here. Brain and spinal cord is pretty important, isn't it? Brain plus spinal cord equals central nervous system, abbreviated CNS. What about everything else? PNS, peripheral nervous system. That's where your nerves are. Listen to this. No nerves in the brain or spinal cord. Get that? It might have been a shock. There are no nerves in the brain or spinal cord. The nerves are all out in the PNS. And you know the biggest one. Okay? Any questions? So we could divide up the nervous system into parts. Is that really accurate? Actually, not so much, the book says, but it's a way to work with this stuff. So they divide it up kind of artificially, but they divide it up so you can understand things better, okay? We've got a lineup of this on another note sheet, so I'll pull that out in a moment. Let's do it right now, actually. Here's your note sheet, the beginning of it, page 1, nervous tissue basics, and it's chapter 11. So we got to chapter 11 already. Did we do 10,
Yeah.
9,
Yeah.
8, 7, 6,
Yes.
5?
Yeah.
But we haven't done
4.
4. 4 is going to get into tissues, but have we talked tissues? Sure, we have. Epithelium, connective tissue, the basic ones, and more than that. Epidermis is what?
Skin plus dermis.
No, epidermis is epidermis.
Oh, yeah.
What's the type of tissue of epidermis? You don't know because I haven't told you yet. What? It's epithelial, but it's got more to it than that.
Correct.
Keratinized, stratified, squamous, epithelium. Was that in chapter 1's notes? No? Just one?
I started with the lab,
Ah, and you saw it there, okay, good. Okay. So we've got tissues to learn. That's why I think the microscope will come in handy next week, probably. Okay, we don't want to squeeze it in today. So let's look at what we got here. We have the nervous system. It's great at communication. Okay, just do this for emphasis. Move your big toe. How long did it take to do that? Nearly instantly. How could you do that? Only if the message got to your big toe. How'd it get there?
Yeah, nervous.
The nervous system. So it communicated to your big toe that fast. That fast. The nervous system is fast. It can be very fast. Okay? Who else can communicate? Endocrine system can. Is it fast? Normally not that fast. Can be profound, but it takes time. Okay? Now, let's go on.
That's a real quick question.
Yes.
You're saying that the brain has no nerves and it was.
No nerves.
And it was something else you
And the spinal cord does not either.
Does it?
We want to go to the definition of nerve, that'll help you probably. So let's look at our breakdown of the nervous system, or at least the way we're dividing it out here. We said take the nervous system, you've got brain and spinal cord, that's CNS, central nervous system. You've got the PNS, that's everything else, okay? That would include the nerves, anything else too. So CNS doesn't have nerves, does not. Now take the PNS. We were just talking about that glass of water. First you had to sense it. So you got a sensory part to your nervous system. Then we had to process, what was that called? Anybody catch it?
Integration.
Integration, good. And then you made the decision to reach out for the glass, and you had to tell the order of your muscles to move, go do that. That's motor. So sensory is coming in, motor is signals going out. And the motor and sensory parts, afferent is sensory, efferent is motor. Afferent, efferent, boy, spelling matters, doesn't it? The letter in the front, I mean, it even sounds similar if you're not careful, but they're a big difference in meaning there, okay? So sensory is coming in, afferent, motor is sending signals out, commands, yes.
Those commands are traveling either to or from the brain directly?
They're coming from the brain,
From the brain?
yeah. And they're also being, they can involve the spinal cord too,
Right.
okay? Efferent and afferent. All right, now, you've already met one of these. You met somatic motor neuron. Where'd you meet it?
In the muscle.
In the muscle, the neuromuscular junction, right? Yeah, that's where you first met it. And I had it there specifically that way, so you know it's a somatic motor neuron. Do you know what soma means? Body. So this is a body neuron, motor one, it's going to a body muscle and telling it to work. Okay, that's voluntary. Those are your voluntary muscles, okay? So you're telling muscles to contract, and that's all voluntary. It's by these somatic motor neurons, or somatic motor nervous system. And another thing here that's not that is autonomic nervous system, short abbreviation, ANS. That did not say autonomic, it did not say automatic, it said autonomic, so be careful about that. This is not voluntary, this is involuntary, so you are not voluntarily doing it. The two parts, the two divisions are sympathetic and parasympathetic, and they work as opposites. They're antagonistic to each other, okay? Sympathetic, what do you think? Fight or flight.
Yeah.
That's right. It's going to be fast. It's that way. What's coming out of your adrenal medulla?
Yeah.
Other name.
Epinephrine.
Epinephrine. Right. You were right, but I wanted the other name too. And then parasympathetic. Guess what it's like? Resting, digesting, and reading. Reading, resting, digesting. Write that down. Parasympathetic is reading, resting, and digesting. That doesn't sound fight or flight, does it? You say, just a minute, there's a bull coming, charging me. I gotta read this book, okay? Just a moment. No, you don't do that. You won't even wanna read a book at that point. Yeah, how to not read it. Yeah, the book. I should have read this before. That's where you should have done it. Timing's everything. Okay. Well, now, what if you saw in the book nerve fiber? What would you think? You'd think neuron, wouldn't you? Well, what's a neuron?
A brain cell.
It's a nerve cell. Nerve cell. Neuron. But that's not right. It's part of a neuron. Which part is it? The axon. So when you read nerve fiber, they're talking about an axon. They're not talking about the whole neuron. Okay? And they do things like this in the book. They'll throw these terms at you, and you'll say, okay, I think I know what it means, and you really didn't catch the whole meaning because you didn't know what the word really meant. Okay? It specifically meant. Nerve fiber is axon. Muscle fiber is
Myofibrils?
no,
Oh, muscle cell.
muscle cell. All muscle cells are muscle fibers. So you think, oh, then a nerve fiber is a nerve cell. No, it's not. It's an axon. Okay? And soma, I already told you, we talked about it, it means body. If you're suffering from psychosomatic issues, what's that mean?
Some nerve problem?
A little more than that, it's more
Like a
interpretation.
connection?
What?
Is it the connection or the process of sending signals from the brain to the body?
It's like the
Yeah,
mind making
that's
the body
correct.
sick.
You're making your body sick by what you're thinking. Psyche is your thought stuff, and somatic is the body. So the psyche part is influencing your body. People can make themselves sick. There's even the possibility, if you get out into the communities of the world, where people are convinced to die from just their brain and their thinking. So if you cast a spell on somebody, I'm gonna die, I die. Yeah. If you believe something enough, it can make a difference. So psychosomatic, your brain and your thinking is actually ruling over your body. And that's a real thing.
Kind of how placebo works.
And the placebo is real. The placebo effect is you get a sugar tablet or something like that, they tell you it's gonna do this, and lo and behold, it does it. You say, a sugar tablet shouldn't have done that. Well, it's your thinking. What you were told you believed and went ahead and happened. So, very interesting. Psychology is very interesting. Not as exact as some of the stuff we're doing, but it is very interesting, okay? So, we talked about this, nerve fiber now, somatic means body, and the somatic motor neurons are doing your skeletal muscles, the ones you control. Neuron is a nerve cell. I got you into that really early, chapter 1. I taught you about neurons being nerve cells. Now, we want to take a look at a nerve cell. If I can find it here. There it is. So here's a drawing of a nerve cell, a neuron. Well, I'll bet you know what this is.
Axon.
Axon. What are these? Boutons, or the other term? Axon terminals. And what's this thing?
The nucleus.
Nucleus. In the neuron cell body. This is the neuron cell body with the twiggies. What are the twiggies?
Dendrites.
Dendrites. Okay. Now the axon starts where? About in here. And they call that the axon hillock. So the axon starts at the axon hillock. And what goes down the axon? Action potential. So the axon hillock is where the action potential starts. Actually, some stuff up here could actually make that happen too. Okay? Action potential goes just one way down, it doesn't come back up. Okay? So here are some terms. I would have redone this and said neuron cell body, so please keep that in mind. This is the neuron cell body with the nucleus and dendrites. And axon hillock is where the action potential starts. Okay, now, let's take a look here. Down here we got three neurons. This one says, I want to talk to my friends. So it does. This one talks to this one right here. Are they touching? No. This is a synapse, but they're not touching. They're really close, but they're not touching. Okay? Over here, this one's talking to this one. They're not touching. All right, let's look at it a little closer. So the axon is not touching, but very close to the dendrite. So what kind of synapse is that? Axodendritic, yes. And over here, this is axosomatic, because this is the neuron cell body's soma, okay? And then this one is talking over here to this one's axon, even up to the axon hillock even. And that's axoaxon. So you're beginning to see there's a lot of conversation going
Wait,
on.
how do you pronounce that?
Axoaxon.
Axioxon.
And so you got a lot of communications going on here, and really fast. This is really fast. This is computer-like speed almost. You know, they're getting the messages out to each other and spreading out. Okay, I wanted you to see that so you get the terms down, what's what here. So what do you insulate? If you insulate anything, it's what?
The axon.
Just the axon, that's right. What do you put on it? Myelin, and it's called the myelin sheath. You put myelin on here, and then it's an insulated axon. But you don't put it on the neuron cell body, never. It's not.